Hi everyone, in this video on coordinate geometry, we'll be working through an exam question involving the distance between 2 points formula. And if you're up for it, go ahead and press pause and try solving this question before watching the rest of the video. Either way though, let's get started. We're told consider the points P with coordinates 1, 2, and Q with coordinates 4, T. We're then told, given PQ is equal to 5 centimeters, find the possible value or values of t. Okay, now as I always do, I'll start by writing SOL for solution. Okay, now the key bit of information in this question is the fact that the line segment PQ equals to 5 centimeters in length. And a very important thing to realize here is that the length of the line segment PQ is equal to the distance between the 2 points P and Q. And that strongly suggests that to solve this problem, we should make use of the distance between 2 points formula. And I'll remind you of that formula in the upper right-hand corner of the screen. Given 2 points with coordinates x sub 1, y sub 1, and x sub 2, y sub 2, the distance between these 2 points, which I'll go ahead and call d, is equal to the square root of, in parentheses, x sub 2 minus x sub 1 close parentheses squared, plus, in parentheses, y sub 2 minus y sub 1 close parentheses squared, and all of that's under the square root. And in fact, I'll go ahead and box that formula. Do make a note of it. And before carrying on, let me also say that the order in which x1 and x2 as well as y1 and y2 appear in this formula is sometimes written in the opposite order of what you see here. For instance, if you're an IB mathematics student, then in your formula booklet it will say x1 minus x2 and y1 minus y2. But don't let that worry you in any way, it makes no difference whatsoever. That being said, I carry on. Comparing the points P and Q to the generic points x sub 1, y sub 1, and x sub 2, y sub 2 we have here, I'll go ahead and say that P has coordinates x sub 1 and y sub 1, and point Q corresponds to x sub 2 and y sub 2. And so with these coordinates in mind, as well as the fact that the distance between these 2 points is equal to 5, we can copy the distance formula we have here, but we'll replace the d we have here by 5, the x2 by 4, the x1 by 1, the y2 by t, and the y1 by 2. In other words, we can go ahead and state that according to the distance formula, 5 must be equal to the square root of, in parentheses, x2 minus x1, so 4 minus 1, so 4 minus 1 close parentheses squared, plus y2 minus y1, so that's t minus 2 in parentheses squared, so t minus 2 close parentheses squared, and all of that's under the square root. Now I'll take care of tidying all of this up a bit. We know that 4 minus 1 is equal to 3, so here we'll have 3 squared, which is 9. So let me just carry on here. That's 5, which equals to the square root of 9 plus t minus 2 in parentheses squared. And so using our perfect square formula, that quickly turns into t squared minus 4t plus 4. And again, I close that square root. And now gathering the 9 and the 4, this quickly becomes 5 equals to the square root of t squared minus 4t plus 9 plus 4, which is 13. And I close that square root. There we go. Okay, now by now you can probably tell that we're dealing with a quadratic for t, but it's underneath this square root. So to get rid of that square root, we're going to square both sides of this equation. And so squaring the left-hand side leads to 5 squared, which is 25. So that's 25, which is equal to this entire square root squared. And if we square this entire square root, well, the square root simply disappears. So on the right-hand side, we end up with t squared minus 4t plus 13. We're nearly there. We're now going to rearrange things to make sure that this looks like a standard quadratic equation. And so for that, I'll subtract 25 from both sides of the equation, so that we have 0 equals to t squared minus 4t plus 13 minus 25, which is minus 12. And I'll go ahead and box that result. There we go. Okay, now at this stage we've used the distance formula as much as we possibly could, and the entire problem is now reduced to solving this quadratic equation. And so if I do that right here, I'll make a quick copy of the equation. That was 0, which equals to t squared minus 4t minus 12. And to solve this equation, we could use the quadratic formula, or we could attempt to solve it by factoring. And I think I'll do that. So to solve it by factoring, I'm looking for two numbers, which I'll call p and q, such that their sum, p plus q, is equal to the middle coefficient, so negative 4, and their product, so p times q, is equal to the constant term in the quadratic, so that's negative 12. So p times q equals to negative 12. And after a bit of inspection, we'll find that the numbers negative 6 and 2 work perfectly. Indeed, if I let p equal to negative 6 and q equal to 2, or I could have also said p equals to 2 and q equals to negative 6, it's completely arbitrary, then we'll indeed find that negative 6 plus 2 is equal to negative 4, and negative 6 times 2 is equal to negative 12. So these two numbers definitely work. And now with these two numbers in mind, we're ready to write this quadratic in factored form. And so we can rewrite our equation as 0 equals to, in parentheses, t minus 6 times, in parentheses, t plus 2. And by all means check, but if you expand these pairs of parentheses, then you'll fall back on the quadratic that we started off with. Okay, now the only way that this pair of parentheses times this one can equal to 0 is if either this pair of parentheses equals to 0, or if this pair of parentheses equals to 0. And so if this first pair of parentheses equals to 0, that would mean that t minus 6 equals to 0, which quickly leads us to the possibility that t can equal to 6. And if the second pair of parentheses equals to 0, well, that would mean that t plus 2 equals to 0, which would mean that t must equal to negative 2. And these two values of t are the two solutions to this exam question. Indeed, the point Q we have here could have coordinates 4, 6, or 4, negative 2. And so as our final answer here, we could write t can equal to negative 2, or t can equal to 6. And we could go ahead and box that in red. There we go. And there we have it. As such, we're done. But just for the sake of illustrating these two solutions, let me quickly draw an XY grid, so something looking like this. There we go. That's X and that's Y. And let me quickly add some numbers here. And now let's quickly illustrate all of this. So we know that point P has coordinates 1, 2. So that would be this point right here. That's the point P with coordinates 1, 2. And so as we've just seen, one possible solution is that t equals to negative 2. In which case the point Q here would have coordinates 4, negative 2. Which would mean that point Q would be right here. So that would be point Q. And the distance between these 2 points, P and Q, would therefore be this length here, and it would equal to 5 centimeters. And the other possibility is that t equals to 6, in which case the point Q would have coordinates 4, 6, in which case the point Q would be up here. And so if I quickly add that, there we go. And so I'll label that, I'll say Q prime, just for the sake of distinguishing it, in which case the length PQ would be this length right here. There we go, and that would also equal to 5 centimeters. And there we have it. Now, drawing it the way I just did here wasn't part of the question, but I do nevertheless feel that it's useful to get an idea of what we're working with. All that being said and done, that's it for this exam question involving the distance between 2 points formula and a quadratic equation.